Welcome to my YouTube channel Raise Acad. Myself Yash Mishra, and today we will be seeing some more questions in thermodynamics. So the question here is, in this there is a process in which there is some compression and expansion process which are happening, and the process compression ratio is given as 8. Okay, and the minimum temperature for this process is 300 Kelvin, and the maximum temperature for this process is 1340 Kelvin. So this is the diagram for this process, P versus V. This is the state 1, 2, 3, 4. So this is a constant volume process. This is also constant volume, isochoric, isochoric, and these are the isoentropic process, or in this process the entropy is constant. Okay, so like this, these processes are happening. Okay, and we have to find what is the heat transfer to the air, what is the thermal efficiency for this process, and for what is the thermal efficiency between these temperatures which are given, which are 300 and 1340. So finding this thermal efficiency between these two temperature, minimum and maximum, are very easy. 1 minus TL by TH, that Carnot cycle efficiency formula. And what we have to find for the process, what will be the thermal efficiency, and for this what will be the heat transfer to the air. So these two things we will find. Okay, so this thermal efficiency for this given between these two temperature without considering process will be same as 1 minus TL by TH, or 1 minus 300 by 340. Okay, so this is the thermal efficiency between these two temperature. Okay, so process 1 to 2 is isoentropic compression process. Okay, so this is an isoentropic compression process. In this the volume is decreasing. Okay, and 2 to 3 constant heat addition process is there. As we can see, PV is equal to nRT, and volume is constant, pressure is increasing, so temperature is increasing, or we can say that the constant heat addition process is happening between 2 to 3. Okay, so what is the heat addition in this process is nothing else but mCp into delta T. Okay, so this will be the heat addition which will be there in this process between 2 to 3. So this Q in we can find from this, what will be the heat addition mCp into delta T. Okay, so neta will be nothing else but 1 minus Q out by Q in. What will be the Q output and what is the Q input? So this Q in is nothing else but 1 minus U3 minus U2, which we have found this U3 minus U2, and this this Q out will be nothing else but U4 minus U1 in this process. So same as how we found the Q in, we can found the Q out. Q out is nothing else but U4 minus U1. Delta U or will be U4 minus U1. Okay, so like this we can find how using the internal energy we can find the efficiency for the process. Okay, so we found this efficiency for the process, and for the between the given temperature the efficiency will be nothing else but 1 minus TL by TH, or 1 minus the lowest temperature upon the maximum temperature. This was which was given between the two temperature efficiency we have to find. So between the two temperature, one will be the maximum and other will be the minimum temperature which is given. Okay, so how to do from the diagram, how to analyze which process is which one, and how this isochoric process and how the heat addition we can relate, and how we can analyze that. In this process the heat addition will be there and the temperature will be increasing, and how we can relate it with the internal energy, and how we can find the thermal efficiency of the process. Okay, so thermal efficiency we can, or the efficiency we can also find by the formula 1 minus Q final upon Q initial, or Q will be equal to delta U or mCp delta T, or we can also find with the other approaches. Okay, so this formula we should remember. Thank you.